Hello and welcome. I am Nicola Migliore. I am the Product Development Manager for the Vcat project at Belogic, and I will be presenting today's webinar. During the presentation, we will be talking about the different file formats that can be used with Vcad and the relative datasets that are exported when first creating your reports. This topic was chosen through a poll we did a while back on LinkedIn. So remember to keep an eye out for both myself, Nicola Migliore, my colleague Francesco Necciari, and the Belogic page over on LinkedIn, where we'll certainly be doing further polls in the future. So if you want to be involved in selecting future topics, keep an eye out for us. During the presentation, we will be looking at 5 different reports using different files that represent a same building. The original BIM file was a Revit file, which we then exported into Ifc and imported into Naviswork to create the various reports that we're going to look at. Also, keep in mind that at the end of the presentation, we will have a brief Q&A section. So feel free to write your questions in the question box, and we'll get to them at the end of the presentation. With that said, let's jump in with our first report of today. So if you see here, we have our 5 different reports. We're going to be looking at 2 reports built using Ifc file, 2 built Revit file, and 1 built using a Naviswork file. So let's start with the first of the Ifc files. This will be a Power BI report using the Vcad Open Viewer using the Ifc file. Okay, so before we have a look, we've created similar reports for each one of the different files. Before we have a look at the actual report, let's jump in right away with the data set that we have available. So if we go over to the model view, we can see which are the data sets that are automatically extracted from the BIM model and made available in our report template when we first create it. So like we will see in all of the reports, the main table we're going to be looking at is always the assets table and then some form of asset attributes or properties table. So let's start with the assets table. The assets table contains the information of every single little object that is defined in our model. They'll have a name, they'll have an identifier, and they'll probably have some classification depending on the different file formats. Then we have the asset attributes table in the case of Ifc, which contains all of the attributes that were defined for all of those objects in our model. Also, in Ifc, we have the concept of a space. So we'll have an automatically extracted space table, as well as an automatically extracted floors table. Both the space table and the floors table have some attributes, data sets connected, and of course, they are connected to each other and then related to the assets as well. So this is what you have out of the box when you start with the Vcad report. Now let's dive a little deeper into these data sets and see what properties each one of them has. So if we go over to the data section, we're going to start with the assets table. Now we're not going to go over every single column here. That would take way too much time and it risks getting boring. So we're just going to focus in on the main columns that you're most likely going to need when you create your reports. Starting from, of course, the assets name. So assets name, pretty intuitive. It's easy. It's the name of the asset. Then we want to look at the asset external ID, which is it's an identifier of my asset, which will be used by the Open Viewer to do the rendering of the model and the specific geometry connected to this asset. I'll show you later where we're going to use it. Also, we have a column which is the asset GUID. This column is very important. It's another identifier of my asset. However, it's an identifier which we are guaranteed to be absolutely unique, of course, but most importantly, that doesn't change over time. So even if I were to update this Ifc file I've used in my report here, if we were to update it and then update also the report to use the new version of the Ifc file, these asset GUIDs are guaranteed to remain the same and remain available. So if I have any external data that I want to connect to my model, this would most likely be the property I'd like to use to connect to it. I may have an asset description as well, and then some classification. In the case of Ifc Files, we have the external entity types, and also we have the type name, which sort of gives you some classification of what type of object we're looking at. Also, finally, in Ifc, you also have the tag column, which again can be useful when you're trying to connect your model to external data sources. Now let's move on over to the asset attributes. Now, at the beginning of the data transformation, when we first extract the information from the model, we don't know what properties are defined in our model. And we need a versatile and flexible solution that can address any type of data structure. So to do that, what we do is we normalize the information. So we'll have every row here represents a property of an object. So for each row, we have the asset external ID, which is the reference to the object, to the asset in my model. We also have here the asset GUID again. And then we have the actual attribute name. So this is the name of the property that we're looking at. And then we go all the way here and we have the asset attribute value. This structure allows us to represent any sort of data structure in a simple, concise way, which can then be retransformed if we want inside of our report, or can be used as is. To give you an idea of how this works, if we were to have a look at one type of property, let's say we have a look at the height property of my objects. So I'm going to filter out height. We can see that for each one of my objects here, each one of my assets, I have a different value of height. And so I can go through and see what this property is valued for each one of my objects. This will be the same structure that we'll use for for attributes and properties, also in the other reports. Let's move along and let's have a look at the spaces table. Again, when we create these IFC data structures, we follow the Open IFC standard, which has an idea of a space. So we're able to create this table. It's fairly simple. Again, we have an identifier of the space, both the GUID, which works as the asset GUID, and also the space external ID, which you would use if you were trying to set up the custom visual, the Vcat custom visual, to render spaces exclusively. In any case, then we have a description, the name of the space, and you're good to go. For the floors, simple again, we have external ID, so the identifier of the floor, and we have the floor name. These are the ones we want to be looking at right now. And then, of course, as I mentioned before, there's a floors attributes table, which works like the asset attributes table. And there's also a space attributes table, which again works like the asset attributes table. So you have the name of the attribute and the value. Now, let's move on over to the actual report and see how this data sets interact with one another and interact with the model. Let's start from the model. So if we have a look at the Vcat custom visual, again, here we're looking at an IFC model rendered through the Vcat Open Viewer. In the Vcat Open Viewer, we need to pass in, for the model to be rendered, an external ID property, which is that asset external ID property that I was showing you earlier in the assets dataset. So right here. This is the only bit of data binding that is fundamental for you to be able to render your model inside of Vcat and to connect that model to other datasets. There are other options, but for today, we're just focusing on this. Now, let's have a look at our report. So starting from the floors, you can see that here we have extracted our 4 floors that we have in our model. We can make selections. We can filter the model based on the floor. So we can see everything that is related to the various floors if we go through them. Let's focus in on the entry level for now. And in the entry level, we can now see all the spaces that are relative to that first floor that we were looking at. So for example, if we focus in on the cafeteria, again, here we are seeing only the assets that are that are connected to the space cafeteria, which is then connected to the floor entry level. And we can see here we have a bunch of tables and chairs. We can have a look at the classifications here over to the left, which are telling us that we have furniture, both chairs and tables. And for example, for these 15 tables we can go through and we can have a look at all of the properties that are defined. So in this matrix, what we've done is we've put a row for every asset, and then we've pivoted the properties, the attributes into multiple columns. So we can go through and we can see the various attributes that were defined for this object and then extracted from the data extraction. So here is that height property that we were looking at before, for example, and we can go through and see all of the properties defined for every single object in our model. Okay, so you pretty much have an idea of how an Ifc file works using the Open Viewer. Let's have a look at how an Ifc file works using the integration with the Autodesk Forge Viewer. So we're going to close this report and we're going to move on to the next report. So Ifc file, which we have imported inside of Forge. Now, one thing to keep in mind, internally Forge manages Ifc files kind of like it does Naviswork files. So it internally follows all the Autodesk hierarchy and data structure for the model tree. Because, however, if you're using Ifc, you're living more in an open and an interchangeable standard, an exchange standard, sorry. We sort of wanted the data set to reflect that. So what we did is instead of using the data set that Forge gives you when you process an Ifc file, we actually, Vcat actually goes over it in the background, re-elaborates the data, and comes up with a data structure that looks like the Ifc classic standard. So if we have a look at the model, in this case as well, what we've done is that Vcat basically goes and recreates that same data structure which we were familiar with in Ifc and that we were looking at before. So again, we have the assets table connected to its attributes, and then we extrapolated information about all of the spaces and the floors with their relative attributes and reconnect everything together, all automatically done by Vcat without needing to do anything inside of your report. Now let's look at the actual data sets. So the data sets pretty much look like the ones we just saw in the Ifc using the Open Viewer example. However, there is some extra information here related to the Forge functioning side of things. So mainly, again, you'll have your asset's name, asset GUID, which is what you would use to connect to external data sources. In this case, we don't need the asset external ID. What we want to look for is the asset Forge object ID. Okay, so this identifier is the one that Forge uses internally to connect geometries to the assets. So it's the one that we're going to have to pass in to the Vcat viewer for it to be able to render our model. And we'll have a look at that later. This is the main difference from the assets side if you're using an Ifc file using the Open Viewer or the Forge viewer. Well, I'll go really fast for the next ones because they're pretty much the same. Again, we have the spaces table structured in the same way. We have the floors table. You can see we've extracted the same 5 floors that we had in the other example. And also for the attributes table, again, it's structured in that same way. So you have an identifier of the asset, you have the actual attribute name, and then you have the value of that attribute for that specific asset. So let's head on over to the report and I'll show you what changes in that case. Again, let's start from the Forge viewer. So you'll see here over to the right, it's loading in our model. It's the same model. It's actually the same file that we were looking at before, just using the Forge viewer. One thing to keep in mind, however, is the object ID. In this case, we're not asked for an external ID, we're asked for an object ID, and we have to pass in that asset Forge object ID field that I was talking about before, so coming from the Vcat assets table. And also, we can have a look at the rest of the report now. So if we focus in on the floors / levels, we can see we have those same 5 that we'd extracted previously. We can again filter our model for the main floor. And you'll see that we actually have some assets that go all the way to the top, the height of my model. That is because those are assets that span the height of my model, however, are related to the entry floor level. And that's why we see them for the entirety of their height. Because when we're reviewing data by floor in the Ifc contest, we're actually filtering the model for those objects, for those assets of that floor. If we head on over to the spaces, we can focus in on the cafeteria again. So you can see here I have my cafeteria room and the assets that are included in it. So again, those tables and chairs. We have the same classification as before, because as I mentioned, we pretty much redo the same data extraction like we did before. And we can go through, for example, our 15 tables and review the same data that was extracted previously. Now, keep in mind, to create this Ifc file, I didn't actually build an Ifc file from scratch. I started from a Revit file and I exported that to Ifc. So the type of data and properties that I have access to here depends on how I set up the Revit extraction. So that's just something to keep in mind if in the future you're doing something like this. Okay, so since I've talked about the Revit file, let's jump into the report built using the Revit file. So specifically, today I have 2 reports to show you using the Revit file. The first one was created using a view, specifically the default 3D view of my Revit file, and one was built using a phase of my Revit file. And I had to build these 2 examples because the way rooms are managed inside of Revit, spaces are called rooms. The way rooms are managed is slightly different. So let's start from the 3D view example, and I'll show you that when you create a report based on a 3D view of a Revit file, you do not have access to spaces and rooms. This is just up to how Revit manages the model. We can see here we have slightly different data extracted. So we have, of course, things like assets, properties, but we also have a bunch of model information. So basically information of the actual Revit project, and also some information about the available views and faces for my model. If we have a look at the model tree, you can see that there's several extra data sets, so more than we were having a look at before. I'll maybe zoom in a little so you can see a little better. Okay, and let's review these data sets. So again, we're going to start with the assets table. That is my main data set. It'll have the information of all of the objects in my model. The properties table is the corresponding data set for the asset attributes table that we saw in Ifc. So here we have all of the properties and attributes of my model. We have these 3 tables down here: family color, category color, and symbol color. These are just some flavor data sets that we set up for the initial templates that are available for doing some theming and things like that. If you're not going to be using them, you can actually remove these from your reports. And then we want to have a look at the levels table. Now in Revit, it is possible to define levels. It is not mandatory, but it is possible. And if you have levels correctly set up in your Revit file, when it's processed by Vcad, you will then have available a levels data set, which we'll look at in a moment. Also, again, as I was talking about before, we have the model properties and the Vcad views data sets, what we'll look at in a moment. And finally, we have the Vcad X asset and X properties. They stand for extended assets and extended properties. These are 2 extra data sets that we recently started extracting from models. They're useful in some edge cases when you're trying to achieve certain functionality, or if you're looking for some specific objects which normally would have been filtered out by the normal data extraction. We won't go into too much detail here about them because the conversation will get a little long and it's a little out of scope. I will, however, direct you to some documentation that we've written both on our website, so you can find it on our blog, And also, there is a video that we've made that goes over everything. I'll ask my colleague Francisco to drop it in the chat. And everyone should be able to just go there and get some more information about these two specific data sets. For now, let's dig in deeper and have a look at the other main data sets that we have available with our Revit file. So let's go over to the data section of our report. Check out the Vcad assets table. This is very similar to what we were looking at before in the Ifc file example. So we have our object ID, which is the identifier of our asset, and is what we will have to give to the Vcad visual to be able to actually render the model inside of the report. We have the name of our asset, and we have the external ID. The external ID is a little like the asset GUID that we were looking at before. It is a unique identifier of my asset. It is guaranteed to remain the same over time if I update the model. So if I have any other external data sources that I want to connect to an asset in my model, this is the way to go about it. This is usually the column you would use to do that. Then we have a little things, so parent ID and some classification for our assets. In Revit, assets are classified on these three levels, so category, family, and symbol. We'll look at those in a moment and how they can be used. Let's head on over to the properties. So the properties table is structured just like the asset attributes table was before. So we have an object ID, which identifies the actual asset. We have the name and we have the value. The extra information we have here is Revit has a higher level of classification above the property names, which sort of groups properties together. So we basically have different sections, so you can have properties grouped if they're about construction or dimensions or things like that. For the rest, it works exactly like it did before. So if we have a look at the name here, and we try filtering out our height property, we can do like we did before, filter that out. And you can see that here we have the value, the height value of all of the assets inside of our model. And we can review that. And again, like before, it can easily be transformed or filtered out. And actually, I'm going to show you later some of the things that you can achieve through transformations from this initial data set. Let's move forward to the levels table. Levels table is very simple. You have the description of a level, and then you have the relationship. So I know each object ID, so each asset, to which level it corresponds. So I know that asset 1922 and 1927 both are related to the entry level. And then we also have a level object ID, which is the object ID that is internally used by Forge to select the level. We try to be as flexible as possible in Vcad. So when you're using the Vcad custom visual, you can actually choose if you want to be filtering based on the level object ID or the level description. That is particularly helpful if you have levels, if you don't have levels correctly defined in your model and you want to have that information coming from the outside, that can still be achieved. Again, we won't go into too much detail here. There's some documentation on our website about that if you're curious. Okay. Next up, we're going to have a look at the views table. The views table is super simple. It's simply a list of all the views and the faces defined for our model with the information if it's 2D or 3D and a GUID that uniquely identifies that view. And this GUID is actually used by the custom visual to render a specific view. Again, on this, there's some documentation showing you how you can update this information to switch the target of a report. I'll show you real quick where you set up that option, and then we're good to go. And the last data set I want to focus in for this example of a Revit file is the model properties table, which, as I said, is some information about the Revit project. So the project issue date, project status, if there's a client name, that kind of stuff that can be defined inside of a Revit file on a project level, and we make it available here if you want to add it in your report. Now, let's head back to the actual report page, and we can look at how the report is slightly different, because again, here we don't have access to the rooms because we're using the 3D view of our model. So there is no filtering based on rooms in this case, but we can still have a similar functionality. We have our different levels. If I show you the actual custom visual, we added in the object ID coming from the assets table, and then we added the floor filter binding to the levels table, specifically the level description in this case. And if you want to see where you would use that view GUID, you can come here to the options. Inside of the Forge options, there's this view GUID. This is telling the custom visual which one of the Revit views or faces it's supposed to render right now. And you want this to coincide with the one used to actually download the data set. Okay. So as I was saying, here we have our floor/levels. In Revit, they're technically called levels, so not floors. And the concept is a little different. So if I show you a filtering of our level, let's say second floor, and we actually zoom in, you'll notice that things is a little different. What is actually happening here, it's clearer if we go over to the entry level. What's happening here is we're not filtering the objects based on their belonging to the first level. We're actually technically sectioning, we're cutting the model at the level line. So you'll notice, it's very clear with these trees, you'll notice we're not only selecting the trees, but we're actually cutting them right at the level line. So you can see where the level line is there. Everything in the model is just cut across. So this is a slight difference in functionality when we're looking at filtering a model based on levels for a Revit model, for example. Moving forward, as I said, we have no rooms, so there was no filtering based on those. However, I know that what we were looking at before is furniture. As I said, in Revit, there is this 3-level categorization of assets. So you have category, family, and symbol. So if we have a look at the category furniture, on the first floor, we can see that we're pretty much looking at the same thing. So we're looking at those tables and chairs. And for each one of those, we can actually go through and review every single property that was defined for those assets inside of my original Revit model. Okay, let's close up this report and let's jump into the next Revit example. Again, what we just saw was an example of a Revit model using the 3D view. Now we're going to look at a report built using a Revit phase. And the main difference is that in phases, you can have access to the rooms. So we're going to wait for everything to load up here. And I'm going to show you the data sets. We won't go through everything again because this is the same model. Other thing to keep in mind, we're using the same identical model. So the actual same Revit file that we were looking at before. But instead of focusing, if we have a look here in the views, instead of focusing, exporting that 3D view, we're actually using this new construction, which is a phase and not a view. What this means is that if we have a look at the model tree, the extracted data is exactly the same. So same tables are created because we have levels, we have the levels, we have the properties, we have the assets, views, and model properties. However, we were able to extract some extra information. If we have a look at the data set for my assets, now, in a phase, I said we have access to the rooms. Rooms, however, inside of Forge, inside of Revit, are managed as any other asset. So they're simply an asset of type room. So, for example, if we're looking at the Vcad assets table, if we filter out this category, room, or rooms actually, you see that we get a bunch of assets. And if we read the name of these assets, so it's copy, print, lounge, corridor, stairs, toilet, these are our actual rooms defined in our Revit model. Because we're using the phase, we have access to this information. So what we can do through some simple data transformation is basically inside of Power BI, and this is one of the good reasons for using Power BI, is because it makes it very easy to do this kind of things. We have the assets table. What we simply do is we duplicate that, we filter it out, we do some minor transformations, and we're able to create this data set. So this transformed spaces should technically be called transformed rooms. That's a bit of a misnomer on my part. But in any case, you'll see we're looking at that assets table like before, which I simply achieved by duplicating the assets table and filtering it for the category rooms. And here I have all of the rooms inside of my model. You can see here conference, copy print, corridor, and so on. This is very powerful because I now have the possibility to manage my model based on the rooms that were defined inside of my Revit model, which I normally wouldn't have with the 3D view. Also, another thing to have a look at. So we have the rooms. What we'd like is a relationship between the rooms and the assets that are contained in those rooms. So we can achieve that as well also by doing some simple transformations in Power BI. If we have a look at the Vcat properties table, specifically, we have a look at the property room, I believe room number. Yes, room number and room name. Both would have done. I used the room number in this case. If we filter out this properties table, we can see that we have a property that tells us what room number specifically, each asset is located in. So if we had a look at 101, we have these 4 assets are in room 101, which is fantastic because it means that I can simply duplicate the properties table, apply these transformations, and come up with this transformed space assets. Again, should have been room assets, but you'll forgive me. That simply gives me the relationship between the assets and the rooms they're in. So again, if we have a look at room 101, these are the 4 assets in my room 101. So I basically was able to kind of recreate some of that functionality that I had out of the box with the Ifc file. I had to work a little here to get it, but it was still achievable. Let's head on back to the report now, over to the dataset overview. As you see now, we have, like before, the rest of the report is pretty much set up the same. So the Forge viewer is set up in the exact identical manner as before. We can again section the model based on the level. Keep in mind here I'm not filtering, I'm sectioning, I'm actually cutting the model. I'm also filtering, but I'm mainly cutting the model. And I have my rooms, and I can actually have a look at my cafeteria. And here we go, this is my cafeteria. Now, one thing that I'll have you note, because of how internally the relationships are built by Revit, in this case, in my cafeteria are also included a door and a curtain wall, which I did not have in the Revit file. This can be due to how I exported the Revit file into Ifc. So I could have played a little around there, or I could have played in the data transformation on the Power BI side. These two would have been easy to filter out if I didn't want them, but I actually found it useful to sort of highlight how things can slightly vary depending on the type of file you're using, something to keep an eye out for that you want to kind of control when you're doing this sort of transformations. In any case, let's focus in on the furniture again. We have our tables and chairs, and we have the properties of all of our tables and chairs as well, which is fantastic. It means we have what we wanted to create with this report. Using, again, I'll repeat it, the phase and not the view this time because we wanted those rooms. Finally, let's have a look at our last report. Don't save this. Let's go ahead and open up the Naviswork example. So this Navisworks file was built simply importing the Revit file that we just looked at inside of Naviswork. Nothing else was done. So we're sort of taking advantage of only partially of the things that an Naviswork will allow us to do, mainly federation, but it works well to showcase the example. So let's have a look at the data sets. In our data tree, these are the data sets that you start out with. So because of how Navisworks internally works, it's constructed to be able to federate models coming from different file types. So, example, in a Naviswork, you can merge together an Ifc file and a Revit file. Because it needs this flexibility, it is very destructured and very normalized. So the bulk of your information is inside the assets table and inside the properties table, because that's how Naviswork needs to work. Also, you have these file name color, file type color, object type color. These again are simple coloring examples that we use in our templates. If you don't need them, you can remove them from your reports to save up space. Which means that basically, when you create a report based on a Revit file, you just have these two data sets to play around with. But everything you need is actually in here. And I'll show you that I was able to recreate a similar situation as the one we had before through some data transformation. Let's have a look at the data sets. So let's start from the Vcat assets table. Like before, an object ID is my identifier of my asset inside of the model. We have the name of my asset. Because it's a Revit file, and as I said, it's thought of to merge multiple files, we have the information of what the source file was. In this case, of course, everyone has the same source file because they're all coming from my original Revit file. And I also have the information of the file type, if that is of interest. If we head on over to the Vcat properties table, it looks exactly like it did before. I have my object, I have my section, I have my name, and my value. So if I want to check out my height property, simply filter out height, and we can see the height of my various assets inside of my model, just like it did before. Now, inside of my Naviswork files, I do not have access to a levels table, as I don't have access to a rooms or space table. However, if we have a look at our, let's clear this filter. If we have a look at our assets table, both the rooms and the levels exist in this data set. So kind of like what I did with the Revit file before, I can extract the information of the spaces coming from my Revit file. Sorry, from my Naviswork files. And I'm also able, so I can create this transformed spaces table like we did before. And exactly in the same way, I can create my space assets table, which is the relationship between the assets and the spaces. Also, what I'm able to do is create a transform levels table. To do this, all I simply did was I went to the properties, I had a look at my properties, and I saw that I have a property of name level over here. This property is giving me the information of the level that each asset is on. You'll see that there is a little formatting here. So there's a level, there's some quotes, then the actual level name, and then a level number or an identifier. So what I did was I filtered out this table, I did some data transformation, I cleaned up this field, and I was able to retrieve the level names, which brought me to the creation of this table. Or actually, sorry, this one was created from the assets table, just like I did with the spaces. The level assets table was created from the properties, just like I did with the space asset table, like before. So fairly straightforward. You need to play around with it a little, but you'll get the hang of it, and you're able to retrieve that same information. Now, last thing to keep in mind, however, I was able to create a levels table in this case because this was a very simple case with a single file. You may not be able to do the same with more complex Naviswork files, especially if you're merging different files from different disciplines and different file types. That may not be an option. But because I had a simple scenario, I was actually able to create this. So let's head on over to our report page. I'll go fast because we know the story by now. I have my floors. My model gets loaded in. I can have a look at my first floor. Again, it now works. What I'm doing is I'm sectioning the model. You can see from my trees, they're actually being cut. I have all of my rooms for my first floor, so I can have a look at the cafeteria. I'll have you note, in this case, the doors and the curtain walls were not included in my rooms, even though I did the same transformations to the data, simply because of how that data was then interpreted by Navisworks. However, I have that slight classification, so I can have a look at my chairs, I can have a look at my 15 tables, and I have the properties for all of those objects. And so through this, I was able to show you how you can achieve similar results using different data types coming from the different file formats. Now, let's talk a little about pros and cons of each one, because some things can be done with one, not with another, and some will be easier or harder to achieve. Let's start from file size. And to show you file size, I'll actually head on over to our file manager. So what you're looking at right now is our integration with Autodesk Construction Cloud. So Vcat for ACC. And these are the 3 files that I used to create the various reports that you saw today. Again, everything started out with the Revit file, and I'll show you my Revit file weighs 16.6 megabytes. When I exported it to IFC, the size grew to 54.6 megabytes. On the other hand, when I imported my Revit file into Navisworks, it shrunk to 4.7 megabytes, so almost a quarter of the original file size. This is important to keep in mind, especially if you're managing very large models. Navisworks is definitely the way to go. Now, let's talk about the pros of the other files as well. So an IFC file is good because it's an open standard. It has that intuitive structure that I showed you at the beginning. So if you want to have access to spaces and rooms, that'll be easier. It required no transformation to achieve those. And it's the file that you usually use if you are having to interact with different construction products. So IFC is usually the communication file format used. So you probably already have those. On the Revit side of things, there's the beauty of being able to export different views and faces. Keep in mind that when you download a template for a Revit file, you'll have access to the different views and faces defined in that model, and you will only receive the data that is present in that view or face, which is good because it means you can segregate your data and make sure that you're shipping out in your report only the minimum required information for the actual report. Also, with Revit, it's possible to federate multiple Revit files through Revit link files. Vcad is able to manage Revit link files, and I'll have you note they count as a single slot, so you're actually able to bring in information from different disciplines all into a single slot and in a single report. However, levels from rooms, specifically rooms, require a little working with if you're trying to achieve that information. It's not as intuitive as an IFC file. Finally, the Navisworks, as we already said, has the best performance out of the 3, especially for large models. It has the best federation because it allows you to federate models coming from both different disciplines, but even different file formats. So you can a Revit file can coexist with an IFC file inside of a Naviswork file and communicate together. That's a definite plus. However, because it needs to be able to do all of this, it's very structured, it's very normalized, so retrieving some information may require some data transformation on the actual report side of things. This covers an overview of the different files. I went a little long, so let's jump into that Q&A session. I'll have a look at a few of your questions, and we probably won't be able to get to answer all of them. We'll definitely get back to you via email or on social media, on LinkedIn to get this answer to you. But let's have a look at the first one. Does the amount of extracted data affect the performance of the report? Yes, it does, in the measure that more data can slow down some of the inner workings of your Power BI report. So the actual Power BI report can be a little slower if you're trying to filter massive amounts of data. So that's something to keep in mind. How's the performance with the Rebar models? I want to use Ifc export from Tekla. So that is very hard to quantify. We have had working examples of specifically Rebar models, and I believe they were exported from Tekla specifically. That was in collaboration with a client of ours. Of course, I cannot show you that. My best answer would be if you don't have it already, start a trial and go ahead and just test it out with your specific model. Because of how much models can vary based on the complexity of the geometries and the number of properties, it's very hard to estimate. What I can tell you is it's definitely been done, so it can be done. But I would suggest you try it out with your specific model. Next up, so does Vcad allow you to extract only a portion of the data contained in the BIM file? Okay, this is interesting. So as of today, yes, in the form of exporting different views from Revit, for example, as I showed you, you're able to define only when you download a report for a specific view, only the data from that view will be available. Also, a bit of a spoiler. We're working on offering more filtering options in the future. Specifically, we're planning to give our users the ability to pre-filter and select a subset of information to download into their templates when they initially generate the template starting from a model. So you'll be able to apply filters and really fine grain and fine tune what you want to have inside of your model, inside of your report. Okay, I'm afraid I'm going to have to stop for now because we're running late. As I said, we'll get back to you for the other questions that were asked. If you have any other questions, feel free to reach out to us either at our website on BIM Services. You can write us an email at support@bimservices.it or reach out to myself, Nicola Migliore, and my colleague Francesco Nicciari. We're both on LinkedIn, and we're happy to answer any questions there. That's it. I'd like to thank you all for tuning in and joining us today. Look forward to our next webinars that we'll be planning in the next coming weeks. And keep an eye out for our social media because you may be able to actually steer us in the direction of the next topic. Thank you, everyone, and you have a nice day and a nice evening.